Thank you.
And our last talk before the break concerns data management plans, and particularly machine actionable DMPs. And it will be presented by Konogan Bouhry. And it has been prepared also by Olivier Collin. So Olivier Collin is the technical manager of the GenWest platform, and Konogan is engineer at the IFB core, and both are working at IIDEA in Rennes. So Olivier and Konogan, the floor is yours for 15 minutes.
Hello.
Thank you. Tu présentes, Konogan? Enfin, tu affiches?
Oui.
Okay.
C'est bon.
So this will be a transitional presentation because there will be a small demo part. I will describe the context and then we'll leave the floor for Konogan, who will make his demo. But at first, I would like to thank the organizing committee for giving us the opportunity to present this work. And I will discuss about machine actionable data management plan for life science. It's a project in partnership between IFB, the French Bioinformatics Institute, and INIST, the Institute for Scientific Information Technology. At first, a small reminder about what is a data management plan. It's a document that will describe how the data is handled during and after the project, what kind of data can be collected, generated, reused, processed, what are the standards and methodologies that are used, and how the data will be accessed, shared, curated, and preserved along the life of the data. As such, it's a key element for any research management process, and it's one of the cornerstone of the FAIR principles. And of course, the DMP is a living document. It has to be updated during the project. If you want to write your DMP, you have many tools that will help you to elaborate this document. And all these tools are based on the same philosophy. They provide a questionnaire and you will answer to the questions, and then it will generate the data management plan. And for most of these tools, there's always an underlying model that was provided by organizations like Science Europe or Horizon 2020. Of course, you can create your own model. And in our project, we saw that, and everyone agrees that there's a wealth of information stored in the data management plan for researchers, of course, but also for stakeholders like funding institutions, DMP hosts, and what interests us is the case of the bioinformatics platforms. And how can we exploit this information to gain some efficiency? And our purpose was to transform the DMP file in a machine actionable data structure and to integrate it in the French bioinformatics landscape. And our work is based on OPIDOR. It's a tool operated by INIST for the reduction of DMP. It's based on DMP roadmap, and it offers many templates that have been tailored for the different French research institutes. And it's operated by quite a large team of people. And how can we switch from the DMP, the traditional DMP, which is a rather static document, to a machine actionable DMP? At first, we have to get rid of the big chunk of text that are in the classical DMP. And we have to find a better structure that can be easily parsed by machines. And we also have to cope with the interoperability process between the different tools, and to use a common data model between these tools. And we are using the Research Data Alliance standard for inter-exchange between these tools. And also, we have to use as much as possible internal and external registries to streamline the process and to help the scientists. We would like to pre-populate the DMPs by getting information, for example, and as you will see in the demo, getting information from the funding agency, and also using standard tools to help and to ease the elaboration of the DMP. And so earlier I was talking about getting rid of the big chunk of text, and this is the model for the machine actionable DMP OPDOR. And you see, of course, the top level entries with the meta information about the project itself, and research output that can be multiples. It can be software, samples, sequencing, data, almost everything you can generate during the process. And you see there are many subcategories, and this arborescent structure gives us quite a lot of flexibility, and it will help the parsing of the information by systems. And if you take a look at the result outputs, there are some different categories, and if you will zoom at the data storage category, you see that there will be the description, the estimated volume units, and you see also that you can mention a specific facility that will host your data. And when you choose this, you will use a special part of the model where you find the whole list of the different facilities. And there are many information that can be used for this. And it's what you saw, so the boxes that are light orange, they are intended to be, and they are using internal or external registries to be much more easier to fill. And what could be the benefits for this machine actionable DMP? So at first, from the bioinformatics manager that I am, it will help us to gain some efficiency in the management of the data on our facilities. It will answer to the question who, when, how, what's happening on our facilities with the data. I also mentioned that it was the first point for the fair, for the adoption of the fair principles by the adopting good practices. And also, it will be a way to better communicate with our users and between the communities. For example, you will see that an end user can request some, or he can pre-configure the computing environment he will need. And so it's a good way to interact around the DMP between the different communities and the different stakeholders of the process. And now I will leave the floor to Konogan.
Thank you, Olivier. So now that we have seen all the benefits that come from machine actionable GMPs, I will make a quick demo to show you how we are working to integrate them in the French bioinformatics landscape. So at first, the researcher will need to fill his GMP, but instead of having to write everything by hand, he will be able to query all the project informations from the IIDEA database. Then once he has finished filling his GMP, he will be able to get his project going on GenOS services just by sharing his GMP. So here we are landing on DMP OPDOR. So I have, for the needs of this demo, I have already created and filled the DMP, but here, all this information about the project was not filled by hand because as I said, we just gave the financing identifier and we were able to import all of this information from the IIDEA. I also described all the research outputs of this project, and for each and every one of them, I answered questions about many topics using the questionnaire. For example, here, I said that I was going to work with the GenOS with GenOS services. And here, for example, let's set an estimated volume of data that we can remember. And now that we have filled our GMP, we can start working with Genware services in this case. So to use our services, you need an account. So I have already created a user account. With a user account, you can start working. You already have some space. But if you are working with a big volume of data, you will need to ask for a project. So that's what we'll do now. So here we require the researcher to give some information about his project, but instead of once again having to fill everything by hand, he can just give us the ID of his GMP, and we are able to query the DMP-OPDOR databases to extract all the information needed in the GMP. So here, as you can see, we once again find the estimated volume of data that I modified in the GMP. So I am sending this request to a GenWest admin, and the next steps of the process will be seen from the eyes of a GenWest admin. So I'm connecting with an admin account, and if I look at our pending projects, we have two projects. We have FitoClim, the project that was just requested. It is linked to a GMP, but we also have, for example, another project that is a legacy project. That means that the information was filled by hand and it's, no GMP is linked to it. So we could either directly accept the project, or for example, if we find that they're asking for too much space, we can adapt it if needed and create the project. And then when we go to the project management page, we can see that it is linked to a GMP. We find all the basic information about our project here, and we can modify it during the project. For example, if more space is needed and more space is available, we can give some more for them. So we can update the project. But now, for example, if we are reaching the end of the project, we can wonder if we can freeze the space and if a long-term storage solution has been found for the data. And this information can be found in the GMP. So here we can query once again the DMP-OPDOR database for our GMP, and we can see that by exploring it, we can see that the data will be stored on a data in array and will be accessible from there. So from that, we can guess that we can freeze the space and make it available for someone else. So this is where we are at the moment, but the goal is to have a bidirectional data transfer. That means that we are able now to extract information from the GMP. But what we want to do is that when we are updating the project on our side, we want to be able to push that update to the GMP. And at the same time, we want to integrate machine actionable GMPs in other tools such as SIG. So for example, we want to be able to extract processes and experiences from the GMP into SIG, let the researcher modify it and be able to push it back to the GMP. So that way we can make sure that the machine actionable GMP stays a living document, but while keeping at a minimum all the manual intervention from the researcher. Thank you for your time, and we are available if you have questions.
Thank you very much, Olivier and Konogan, for this very nice description. Are there some questions? I'm sorry, I missed two attendees that were raising their hand. Is it still relevant for Maureen Trucci? I give you the microphone, I don't know. And Stefan B, I don't know. But I'm afraid it was from preceding talks. So if anybody else has some questions, please raise your hand, or panelists could ask some questions. My comment is that it's very nice to see at least finally how these GMPs can be useful for the researcher that spent much time to fill it, because it can really optimize the way he interacts with the working platform. So it's very, very interesting, and future evolution are also interesting. So Nicolas Jess is asking, is this version in production already?
No, it is not yet in production because we are still working with DMP Opidor. So it's not yet in production. It's still under development.
But it will be, there will be a version, a production version, I guess, October, November. It's the roadmap of the INIST for the release of this this version. So they are working on the machine actionable Opidor version.
And they are doing a kind of tour in the laboratories. Be attentive. Maybe you have some invitation to such video demonstration. I attended one recently, and really it was very useful to see how easier it becomes to fill all these fields, because many are connected to registries. So you just need to choose the proper item and to select it for your field, and it's very getting much progress. And
they are also searching for testers.
Yes.
So if you would like to be a tester, you can just write me, and I will transfer your mail to the team.
Yes, yes, it's a very interesting experience. So I think we have to stop. We are over the time. We swallowed the break, but we will still do a break because we need. So, but I propose to make a 10 minutes break, if you don't mind, and to start again at 17:23. Is it the time? Or let's meet at between 20 and 25 and start at 25. Okay? So see you.
Thank you.
See you in 10 minutes. Thank you. Thanks to all the speakers and also the attendees.